one of those things that we have to deal with is that things like Ethereum act as a client server. And there's no central server for Ethereum, but you still connect to it at some IP address for access to the distributed network. And in our case, we're just going to have a single node, but we are going to do some client server stuff. So this particular case, let's go over here and let's start up a server. It's in assignment 4, and there is enough there in the server that we can at least start it. It doesn't have everything because you've got some homework to do on this. But if we go into bserver main, and let's look at run server. You can run this line on Windows without all the other stuff. Just run the server itself in a separate window from the one that you're going to be running in, and leave off the ampersand. So here I'm just going to run this script. If one's already running, it'll kill it. But you'll notice that it's going to end up at port 127.0.0.1.9191. So that's where we're going to talk to it. And let that get started. Let that get started. Okay, in my particular case, it doesn't output much, but it is running out there. And there is a configuration file that has information on the accounts that it has. This is not its first transaction for these accounts, but instead of just running a single program that does a transaction, this is now sitting there running as a server. The other thing that it has done is I've given it a parameter on the command line to say, okay, be a server, run at this address. Now, as soon as I do that, I'm going to have the opportunity to be able to go in and bring up the browser and talk to that client. Now, I happen to be running it where I'm on 2 different machines. So if I do on this Linux computer, ifconfig, and I pipe it to grep 192, I can find that this computer I'm running the server on is .36. You're probably going to be running it on a single computer, so you want to put in a different IP address. You want your local host, which is 127.0.0.1. But I need to put in 36 and a port number of 9191. Now, if I just hit return at this point, it's going to actually do an unusual thing. It's going to give me a file listing for the directory, which is kind of interesting, but this is not really necessarily desirable. I mean, there are things like PID file here that I can bring up, and I can find out what the process ID is of the server. If you were running in this production, you probably wouldn't want it to do that. But what I want to do is I actually want to bring up a specific communication endpoint, API status, and bring up that, yes, the status is a success. Now, when you do a request across a client server, normally there are a couple different things that are going on. The first one is what kind of a method you're using for this request. And there are about 15 different methods, about 5 of which are commonly used, and one of those is GET. All of our requests are just going to be GET requests. Now, in a production server, you wouldn't be able to get away with that because GET requests encode everything on the URL, including if you're sending usernames and passwords instead of encrypting it and encoding it in the body. So lots of things like user authentication really should run via some other method like POST. And there is this general standard called REST where they use get, post, put, and delete to implement access to database resources. And there are other security methods that they use to make this work for other applications. For ours, we're just going to do GET requests. It's simple, and we don't have to worry about making this work over a network with encryption and HTTPS. We're not dealing with that kind of stuff. So if you look inside here, you'll see that in the URL, it has API status. That's our communication endpoint. We're going to come back to that, and I'll show you where that is in the code and how that gets turned into a call to some code. But basically, what this status message did is it said status success. It told you that it's your Go server running and that your request had all this information in it, things like what your browser is, And then down here at the end, it said that its response header was application JSON. Now, when you send back responses, you need to get the right content type for the response. And a binary image like a PNG doesn't come back in the same format as application JSON or HTML or plain text. So we're going to see in the code where I've actually set that up to be the case, to say that yes, I am serving this, it is application JSON, and there are other things in the request and the header here, but these are the ones that I printed out on the status. The big picture is once you get it compiled and you run it and you do something like this, you actually have a running server. You're actually talking to software on another machine and making requests and getting back responses. Now remember, our first thing that we did, we just got back some text. Okay, it wasn't very much, but it was some text. And I went in and pulled up a plain text file that had a piece of information in it. So this server that we've got going here isn't just capable of serving like calls into code, it can also serve files. Now, when we get to things a little bit later in the semester and it's talking about Web 3, you have a server on a server, and that server doesn't just serve up calls into Ethereum or Cardano's network, it also serves up the files that make your presentation, your interface, all of this other HTML stuff, cascading style sheets, all of that stuff, as well as serving up access to the blockchain. Now, blockchain access tends to be kind of specialized because we don't just have access to a database where, you log in with a username, password, and it keeps your credentials on the server, and it turns that information into permission to go change data. Here we have a system where we say anybody that has the credentials can go and change whatever they want, provided their credentials match. And we use strong authentication, public-private keys, and we give them access to the accounts that belong to them, whatever funds there are. So that is what the digital signature stuff is really all about. It's a different kind of authentication model, and in this authentication model, you get control over what is owned by this public-private key. The public key is public, which means the network knows about it. The private key is in a key file that you should keep very private so you don't lose it. Now, most systems, I would say all of them, but I haven't tried every blockchain out there, have different kinds of key files that they store. But by and large, the key files really have one piece of information in them. They have a private key. And in that private key is what the wallet data is. So let's look at, in our case, where it says wallet data. And I've got 3 keys in here that I've checked in. I'll share the passwords with you for these 3 keys, but we'll bring one up. And here is a piece of JSON that says, this particular key is associated with this address. You notice that address is also in the file name. This is the standard format that Ethereum uses, and I've copied it. That it has a cipher that is this AES 128 CTR. And here is the ciphertext. That ciphertext has your private key in it, and it's encrypted with a password. And it says that the password is encrypted with scrypt, which is a standard hashing algorithm to use the password. And then there are a bunch of other parameters in here, like salt and a MAC and other things. But basically, this says, here is a public-private key that's encrypted, and you can't read it. So this public-private key is protected with a password. Now, the client keeps on its side these public-private keys. And what it does is it says, if I want to access something that requires a transaction, like I'm going to transfer tokens from me to somebody else, or I'm going to spend Bitcoin, I take it and I build a transaction, and then I do a signature using my private key that the server can verify with the public key for that account. And we're actually going to go look at the signatures first, and then we're going to see how these things interact and where they go in the code. But this means that Inside the code, we have to, like on the client side, generate this signature information in this transaction. On the server side, we have to validate it. And that's what's in homework 4, is both the client and the server. Now you'll notice that I have this directory I'm in that says wallet client. And if you go looking in here at client main, you'll see that it has options and different things that you can do. Now, the browser over here is a general purpose client for lots of sites, and we probably all use it for something. This is a specialized client that we're building that interacts with just our network. So it interacts using the command line, and it has a series of options. One of those is the command send funds to, or list accounts. And let's do, not all of these are implemented. You have to implement the body of send funds to. But list accounts and list my account, we can actually run that. If we do boy, I did type that right. So here's the available accounts that are built into the system. And it doesn't tell you the value in each account, but you can look that up with the list of specific account. There's examples in the make file of running that. But here's something that we've gone from a client and we've gone out to the server and we said, give me a list of all the accounts. And here's the accounts. Now, the first thing to note about these is the accounts are basically pieces of a public key. They're 24 out of 32 bytes of a public key. And each one of these accounts, if I go into the make file, we can see not just server status, list accounts. Here's one of the ones, test003, where it lists for a particular account that it has 50,495 tokens. So this particular account, okay, has a certain number of tokens associated with it. You can tell since I've been moving 55 tokens at a time that I've run stuff a bunch of times. And this has been the destination of a bunch of transfers. But here it is, we're accessing it, we're asking questions about it. Now, to access the amount of information isn't something that requires a transaction. The one that requires a transaction that is signed is send funds. And that's the one that you get to implement. So if we go back into the code, client main, and we go looking down through it, there are commands that you can run directly, okay? But we're interested in this echo. You notice it doesn't make any call to anything. It just runs directly. List accounts basically says, take this host, which is where the server is, and produce this whatever is the destination of the server, and print that together with API account list. And then it turns around and it sends it with this function doGet, which makes a GET request from the client to the server. And if the status is okay, down here on this line, 200, that's a good status, then it just prints out the body of that request. Otherwise, it prints out an error. And that's what goes on in list accounts. Shutdown Server is a request that you can send to the server to shut it down. This has no security on it, so anybody could send this, but since you're probably just working on your own machine when you build this, that's not a big security problem. You can get server status, that's the API status that I ran a few seconds ago. And you can pull up what I did in test 3, which is account value, which looks just like this. You can generate a new key file, which is going to prompt you for a password and generate a new key. You'll notice that when it does this new key file, it doesn't access the server at all. The key file is local to your system. So if you do this and you use a password, make certain you keep track of your password, because if the password is gone, the encryption on those key files was AES 128-bit, and you're not going to get it back if you lose the password. Okay? Now, this one is completed for you, which is validate signed message. And the client side is done. The server side, you have to implement the validation code. We'll get to that in a little bit. But here is the I read in a key file, I got a passphrase, okay? I generated a random 20-byte message, okay? I signed it. I called this thing on the server to validate a signed message, and you'll notice that down here it has actual parameters. It's just, instead of just getting a particular URL, it says the parameters are account and what account name is, the signature and where the signature is, and then the message and what it sent for the message. And then it sees if you got a successful return value. We're actually going to run that with a working copy of this server so you can see it. But before we get to that, we want to take a look at the command line and how the signatures work. And then the other one that you get to implement, and again, you get to implement both the client and the server side for this, is send funds to. And here you're working on both sides instead of just the server. So what I would do is I would start with one of them, probably the client, and implement the request, because that's the simple piece. This is the piece where you take the stuff, invalidate, and you add to it, printing out a message that has the from account, the to account, the amount is the message that you're going to sign, and all of that stuff gets put together in a request, and you check the return value. With the server just having a return of, yeah, it's okay, I did it. It doesn't validate anything. And then it works, and you say, okay, I got the client to work. Now let's go work on the server, and let's add in the code that does the validation. And since, I am giving you the code in the command line stuff that does a validation of a signature, yeah, it's going to require poking into it and seeing how it works, but it shouldn't be horribly complex. So let's go take a look at the command line and see how that piece works and what signatures and validation of signatures looks like.